All right, so let's start with these first couple of examples to develop the idea. So let's graph the graph of e to the negative x. So e to the negative x, looks like this. Y equals 0, is this line right here. X equals 0 is this. So make sure we get these correct. This is a big deal. If you get these wrong, then you get the area bounded wrong. So this is the area that's bounded by all four of these. Okay, so now to find that area, you build rectangles to find the area bounded. So I can see that the bottom of the rectangle is always touching the x-axis. So the area will be the height of the rectangle, which is e to the negative x. Width of the rectangle is dx, and I build rectangles from 0 to 3 on the x-axis. So these have to be x values, correct? X values, because I'm doing dx integration. All right, so let's look at this one, sine of 2 sine of 2x. I know that this changes the period, so that'll be the period of 2 pi divided by 2, so it's now going to be a period of pi. So one sine wave fits between 0 and pi, so I'm just going to draw the x-axis longer. And where am I looking at? So I'm looking just between 0 and pi over 2. Well, that's halfway, so that's right there. So the y equals 0, again, make sure you're really clear that this is y equals 0. So the area that's being talked about is right here, because this is x equals 0, x equal pi over 2, so this is the area bounded. So let's look at the area will be the height of the rectangle, which goes up to 2 sine of 2x, and the width of the rectangle is dx. I start building rectangles at 0, and I end building rectangles at pi over 2. Again, these are x values. All right, and this one does say solve the integral, so let's go finish in doing it. So I carry along the 2. I know the antiderivative of sine of 2x will give me a negative 1/2 of cosine of 2x between 0 and pi over 2. So the 2's cancel, so I get a negative, and then I put cosine of 2 times pi over 2. I'll go slow here to make sure you see what I'm doing. Subtract off a negative cosine of 0. So this gives me cosine of pi, which I know is a negative 1, times another negative, and then plus cosine of 0, which is a 1. So here I get a 1 plus a 1, so that gives me an area of 2. Area bounded will always be a positive quantity. All right, let's look at this next one. So now I've got the area bounded between two separate curves. So we've got y equal 9 minus x squared, so it's a parabola shifted up by 9, upside down, and here's y equal 5. So this is the area bounded. So I want to encourage you not to color it all in, just put dots, because I'm going to want to see the rectangle. You're going to need to see the rectangle. So this is the top of the rectangle right here, and this is the bottom of the rectangle right here. So finally we're getting to use this idea at the top here. So top curve minus bottom curve. Top of the curve minus bottom of the curve. Top of the rectangle, subtract off bottom of the rectangle. Okay, so this is the height of the rectangle goes in here. Height of the rectangle. So the height of the rectangle will be, we always measure from the x-axis, right? So this is the x-axis here. So I measure all the way up to the 9 minus x squared. And then I'm going to subtract off the distance between here to 5. So that will give me this distance here. And that's the height of the rectangle. This is the width of the rectangle. And the height times the width gives me the area. And the integral takes me to add a bunch of them up and let the limit of them go to 0. All right, so now where am I going to start and end building the rectangles? So these must be x values. So I need to find out where these graphs intersect, and you know how to do that. 9 minus x squared is equal to 5. So let's bring this 5 over here. So 4 is equal to x squared. So I see plus or minus 2 are the x values that would be here on the x-axis. So from negative 2 to positive 2 is where I'm going to build the rectangles to find that area bounded. All right, let's just do one more here on this page. So here I've got 4 plus x squared. So it's shifted up by 4, still upward facing parabola, and here's y equal 9. So this is the area bounded. Again, don't shade it all in because you're going to need to see the rectangle. I'm going to need to see the rectangle on your paper to understand what you're doing. So the height of the rectangle is from here to here. So I need to find that distance. So we're measuring everything from the x-axis. So I want to say go all the way up to this and then subtract off this distance. So the height of the rectangle, let me just kind of develop the idea over here. So the height of the rectangle will be go all the way up to the y equal 9 and subtract off the parabola 4 plus x squared. Be really careful to put those parentheses in because you're subtracting off the whole parabola. So the area will be height of the rectangle times the thickness of the rectangle, which is dx. And where am I going to be building the rectangles from and to? 9 is equal to 4 plus x squared. 5 is x squared. So I can see I'm going to be from negative root 5 to positive root 5. And that is the area bounded.